Hello, and this time we're looking at simplifying some algebraic expressions where there's a fraction. So in this case, all of mine are fractions, but if you've got something like 4a divided by 2a, you can just write that as a fraction, because that's what a divide symbol is. It's sort of like this number over this number as a fraction, and you can just rewrite that 4a over 2a like that. I find that easier to see the cancelling sort of style when it's in a fraction rather than a divide. So I recommend you do that first if you've got, if you've got a question where it's written with a divide sign. So each of these we're going to treat the numbers separately to the letters. So we're just going to do all the numbers. So 12 divided by 6, we can cancel that down to just 2. And actually the letters don't cancel because there isn't anything to cancel with. It just says x, so the answer is 2x. Here we can cancel the numbers, do all the numbers first. So 24 and 6 is going to divide evenly to give me 4. And then a divided by a, well, anything divided by itself, so like 7 over 7, 10 over 10, or indeed unknown number a divided by the same unknown number a, they all equal 1. So when you have the letter on the top and the bottom, you can just cancel them. So the answer is just 4. Okay, now this is where it looks more like doing each thing separately. We're going to do the numbers. 14 over 7 gives us a 2. A, well, there's no A's on the bottom, so we still have an A. The B's, well, there's a B there, but no B's to cancel. And then the C's cancel, because there's one on the top, one on the bottom. And there's our answer, 2AB. And the last one, we've got 22 over 2, doing the numbers first. X doesn't cancel with the X, because there isn't another X, it just stays itself, it's just X there. And then there's a Y there and a Y there, so they're going to cancel. So the answer would be 11x. Now, if there's a squared, just sort of throw it, because they didn't put any of these in, if there's, or any power, it doesn't have to be squared, but if there's a power, that tells you, if it's squared, that there's 2 y's on the top and 1 y on the bottom. So in this situation, you would say, okay, well, there's only 1 on the bottom to cancel with one of the ones on the top, which leaves 1 on the top. So the answer to this would be 11xy. Well, what if the squared was on the bottom? Well, then again, one of these this 1y, cancels with one of these 2 y's, and you'd be left with 11x over y. So if there's powers, it's fine. It just means that, that tells you how many of those you have, and you can just cancel with the smallest amount, because you can't, just like you couldn't cancel this x because there isn't an x on the bottom, you can only cancel one of the y's with the second y, but it leaves the original because you can only cancel one y with one y. Now, when you've got an add or a take on either the numerator or the denominator, you can still cancel things, but only if that value is in all of the terms. So that means that anything we want to cancel needs to be in this bit, and in this bit, and in the denominator. So it makes sort of like a smiley face. But anyway, I digress. Got to be in all three, otherwise you can't do it. So 8t and 4, and a 4 on the bottom, 4 does go into 8 and 4, and obviously the 4 on the bottom. So we can get rid of those. 4 goes in there twice, goes in once, so you make sure you put the -1. That doesn't disappear. I know here it sort of looks like they just disappear, but they become ×1, and we don't bother writing ×1. But here it's got to have a 1, because we're taking it away, so we do need to write the 1. And over here would be over 1. Well, all right, we don't need that one, because dividing by 1 doesn't do anything exciting, so we'll leave it like that. Same thing here. As long as there's this number, we can cancel the 6 because it's in both of them. If it was only in one of them, we couldn't do it. So 24 over 6 is going to give us 4x, plus 18 over 6 is going to give us 3. No need for a denominator. Now here's this squared thing coming in. A squared, there's an a in this term and there's an a here. So because there's an a in all of them, we can cancel it down. So we only lose one of the 2 a's, so we've still got an a. Plus, we lose the a but keep the 3, and then the a on the bottom is gone, okay, because we've cancelled an a everywhere, so it would be over 1, but we don't bother writing over 1, we'll just leave it like that. And finally, there is a 2 in every term, 2, 2, and the 6 has a 2 in it, so we can cancel those down. That'll be 1, 1, and a 2 there. 3 there. 6 divided by 2 is 3. And then there's an a in each of them. A squared there, a and a. So 2 a's there, 1 is left. An a there and an a there, both cancel. So it's just going to be a minus 3. Yeah, we don't need that any denominator because the 2's evaporated and the a has. So the key thing is you can get rid of things if they're on the top and the bottom. They're going to divide away to 1, and so you don't need to write them down. And you can do the numbers separately to each of the letters, just do them all independently and just write down what you got. If you've got powers, then that just tells you how many there are repeated of that, so you just cancel as many as you can, and if it was a to the 7 there, and you cancel one of them, it would be a to the 6. You've just lost one, so it's just one fewer. And then if there are adds and takes and things, then you need that value to be in all of the terms. And if the denominator had an add as well, if it was 3a plus ab all over ac minus a, just a on its own, then we can do it for a because there's an a in all 4. But if there wasn't, if this was minus 4, you can't cancel that at all because there's no letter or number that's in all of the terms in the fraction to cancel it down. So that is as simple as it can get. If you have any questions, pop them in the comments, but otherwise, cheerio.